Here is another topic in section 6.1 is the concept of power functions. So basically any function that you can write like this, where you have f of x equals a number times x to a power, and k and p, the k is the coefficient in front, and p is the power there. Those just have to be non-zero constants. That's called a power function. So some examples of power functions are this one, for example. If we say v of r equals 4/3 pi r cubed. By the way, this is a function that gives you as output the volume of a sphere or a ball with radius r. And in this case, the k is the whole thing in front, the 4/3 times pi, and the p is 3. So that's one example of a power function. Another one is, let's say you have an inverse variation relationship, like y equals 7 over x. So this is an inverse variation, just like from section 5.4, because the x is in the denominator with a constant number in the top. And with this one, it's not written like that yet, but you could write it in the form of a power function, y equals 7. But this x in the bottom, you could think of it as x to the power 1 there. And if you write that in the numerator and turn it into x to the power -1, because remember x to the -1 is the same as 1 over x, then it's a power function, and you can see that the k is 7 and the power p is -1. All right, so here's an example of where we can figure out if these are power functions. So we have these three examples of functions, f, g, and h. Which one of them can we write in this form? So with this one, there's this +2. There's no way to combine these two terms. So this one has an x to the 4th, and this one doesn't have an x. So if these like terms can't be combined into one term without a plus in the middle, then it's not a power function. A power function is really just one term. So a term is something that is being added or subtracted. And if you have just one term, it's not separated by plus or minus. Here you have two terms, and there's no way to combine them. So that means they can't be written as just one term. So that is not a power function. And for part B, I'll do that one here. Let's see if we can write it as a power function. So I'm just going to take it and start by noticing something. The 1/3 and the x to the 4, you can write it as two separate fractions, like so. Because multiplying those fractions together, you would just get that original thing. So, and then the 1/x to the 4, is really, you can write it as x to the -4. That's what the definition of a negative exponent is. So this is a power function, and we can say that the k in front is the 1/3, and the p is -4. So let's see, with c here, you could write this, and by the way, the steps I did here, you can kind of skip this step. If you just want to say, oh, I know I can take the x to the 4th and bring it to the top and write it as just 1 times x to the -4/3 in just one step without separating it into two fractions, that's okay. I just like to show really why that works a couple times, and you can do it either way. Anyways, the h of x here that we have, we could take that x to the 3 in the denominator and move it to the top, because it's kind of like what we have is x plus 6 times 1 over x cubed. And you don't always have to do the step once you get used to it. And write it as x plus 6 times x to the power negative 3. That's the same thing. But the problem is this thing here isn't just a number. The k in front has to be a number like 1/3. So you can't have a variable there. So it doesn't work that way. You could try distributing stuff into here. You could do x times x to the negative 3. And then that basically gives you two different power functions with two different terms that can't be combined. So this is not a power function. Okay, now let's do this next exercise here. I definitely want you to do this on your own, kind of like some of the ones we did last week, where do it on your own first. If you get the right answer, that's great. If you get the wrong answer, I want you to write your wrong answer, just leave it there, don't erase it, and also write the right answer next to it, because it's an important thing to be able to catch your mistakes here, because there's a lot of common mistakes with this, and I want you to be able to catch them. So with that in mind, let's pause here. Here's the answers for that. I'm showing this extra step in the middle here. You don't really have to show that step. You could just go straight to the end. I also showed you the values of k and p. One thing that you might find tricky is when you just have over x by itself. Remember, x by itself is the same thing as x to the power 1. So there's like a 1 there, and when you take it to the top, that's why that's negative 1.